Hello everyone, my name is Ritanshu. Welcome to the channel for AI and machine learning series. So in the first video we have seen what is AI, what is machine learning, what is the difference between conventional programming and machine learning programming, supervised and reinforcement learning. So in continuation of that, I just revise what is the last topic in brief, and then I will continue with the next topic. So we have seen in the last session what is supervised. When we have a labeled data, then it is a supervised learning. When we have a unlabeled data, then it is a unsupervised learning. And for the reinforcement learning, it is based on the rewards. It is based on the what action I have taken, and accordingly the new action or the new path will be defined. The overall what the suitable path or what is the least consumed path to achieve the goal, that will be taken as a final outcome. So reinforced learning is an area of a machine learning. It is about taking suitable action to maximize rewards in particular situations. It is employed by various software when we have a various software machines to find the best possible behavior or path. It is just like a game. Take example of a chess game. To achieve the best goal, or let's come to the simple example, snake and ladders. So when we have reached the 100 points, what is the best suitable path and what is the minimal distance path? Post iterating all the paths, what will be the best suitable path, minimum length path, that is the best possible solution. So this experience or this iterative task used to be done in the reinforcement learning. The best example of reinforcement learning is the chess. So we can just compare supervised learning, learned by the using labeled data, trained using the unlabeled data, and works on interacting with the environment, closed loop and feedback system. Reinforcement machine learning example is self-driving cars or the gaming. Unsupervised learning examples are like recommendation systems and anomaly detections. And supervised machine learning programs, you can see risk evaluation and the forecast sales. Now, today we are going to discuss how to choose the best algorithm, because in the market or in current situation, we have multiple algorithms, and for a specific problem, how to choose which algorithm we should apply. So if you see, I have listed multiple algorithms over here. I have segregated those algorithms on the machine learning algorithms, advanced machine learning or the deep learning. So you can see we have a linear regression, logistic, decision tree, random, PCA, SVM, k-means, multiple we have. So now to solve a specific problem, what should be the approach to choose the machine learning algorithms? So just see this diagram. Now, before choosing an algorithm, we should identify what we need to predict and what kind of data we have. Suppose we have to predict someone's salary, then in that case, we have to go with supervised learning algorithms. If we don't need to predict a numeric things, we have to take some decision on the basis of yes or no, or some classification kind of things we have to predict, then we will go with the supervised learning classifications. Now, suppose we have to predict a numeric, then we have to see whether we need a speed or accuracy. If we need a speed, then we have to choose decision tree or the linear regression. If we need a accuracy, then we can go with some advanced machine learning like neural networks and some random forests for the best accuracy. That is the advanced machine algorithms. Now, suppose if we don't have a numeric data to predict, we have to classify or we have to some categorization kind of a thing, then we have to go with the supervised learning classification. And here also we need to see whether we need speed or accuracy. If we need accuracy, then we have a SVM, we have a random forest, we have a neural networks. If we need speed, then we have to see whether it is explainable or not, or how to expand that. So in that case, we have to choose whether we need, we have to choose decision tree or we have to check whether data is too large or not. So if we don't have a numeric data, then we have to consider one more parameter. Whatever the input data set we have, that data is too large in the training or it is small. So on the basis of that, we use to select either SVM or naive Bayes. Now, if for any problem we have to reduce the dimensions, what is the mean of reducing dimensions? Suppose we have a 10 input variables. 10 input variables is not very significant to predict the output, then we have to reduce the dimensions. Let's take an example. Suppose to predict anyone's salary, we have an input parameter age, experience, technology, male or female, gender, or which college, something like these 5 parameters we have. After seeing the output, the salary, we have seen from which college he has passed out his BE or BTech, it doesn't matter. So in that case, that dimensions can be reduced. On what basis it has to be reduced, on what analysis we have to done? For that also we have algorithms. So on the basis, if we have to do the dimensions reductions, then we have to either opt PCA or different algorithms is there, SVD or LDA. So we have a PCA, we have SVD, we have a LDA, or if we don't need a dimensions reductions, every dimension is equally important, then we have to see whether we have a labeled or we don't have a labeled data. If we have a labeled data, what does it mean? We have to choose some supervised learning algorithms. If we don't have a data, labeled data, then we have to choose the unsupervised machine learning algorithms. In unsupervised machine learning algorithms, we have to see whether the data is hierarchical or not. If data is hierarchical, then we have to choose some hierarchical algorithms. Otherwise, we need to specify the K, because most of the clustering algorithm or unsupervised algorithms needs K. K means in what should be the maximum clusters when we are predicting the values. So accordingly, we will be doing that. If we have a label data, then we have already discussed how to choose that. So this is the overall cheat sheet, how to choose the best algorithm to solve your problem. So in this video, we have mostly covered how to choose the algorithms and what is the different kind of algorithm categorization. So my basic idea was in first 2 videos, I have covered basics of the artificial intelligence and the machine learning. So basically, I'm just briefing what we have covered till now. Machine learning programming versus conventional programming. When we have a concrete business logic, then it is a conventional programming. And when we use ML programming to take some decision, it is the AI programming. What is the basic steps for the machine learning or for the AI programming? First, we have to pre-process the data. Then we have to apply some algorithms for learning. And after that, we evaluate that. And that model is used to take some predictions. This is the categorization, supervised, unsupervised, and reinforcement. Supervised when we have a label data, unsupervised when we don't have a label data, reinforcement when we have a reward and punishment mechanism to identify a path, like snake and ladder game. So the best example is chess, automatic chess winner. This is the table for comparison if you just see. And in last, we have discussed about the how to choose the machine learning algorithms, because we have a multiple algorithms currently. So these many algorithms we have. From the next session, we will be covering one by one each and every algorithms. We will start with linear regression. Thanks for watching this.